Hello, everyone, and welcome to the May episode of the Science Talks webinar. My name is Christine Meyer, and I am the Alumni Relations Program Lead for the Faculty of Science. We acknowledge that the University of Alberta is located on Treaty 6 territory, and we respect the histories, languages, and cultures of First Nations, Métis, Inuit, and all First Peoples of Canada, whose presence continues to enrich our vibrant community. Our presentation, Software Development, Building Better Code Through Reuse, is about 30 minutes in length, followed by a question period. We'll be collecting questions throughout the presentation, so please type your question into the Q&A box, which will appear at either the top or the bottom of your screen, depending upon your setup. Feel free to enter your questions at any time. You will not be interrupting. At the end of the presentation, these questions will be shared with our presenter to address, and we'll get to as many of them as possible. During the presentation, a video of the presenter will appear on your screen, and if it happens to obscure the presentation material, you can move it by simply clicking on it and dragging it to another area of your screen. And now it is my pleasure to introduce Frederick West, Acting Dean of the Faculty of Science. Over to you, Fred.
Well, thank you, Christine. And I'd like to thank each of you for joining us for this month's Science Talks webinar. It's always so great to have the opportunity to connect with you all and share some of the excellent research that's happening here in the Faculty of Science. We've really been pleased to welcome our students back into learning in person this past semester. And coming up in June, I'm looking forward to Convocation, which we'll be celebrating in person for the first time in 2 years. This is always a wonderful time of year, and I'm looking forward to seeing students as we celebrate their achievements. It's also an important milestone. I look forward to welcoming this year's graduates as they too join our alumni community. So it's my great pleasure today to introduce our guest speaker, Dr. Sarah Nadi. Sarah is an assistant professor in the Department of Computing Science here at the University of Alberta, and also a Tier 2 Canada Research Chair in Software Reuse. She obtained her master's and PhD degrees at the University of Waterloo and joined U of A in 2016. Dr. Nadi leads the Software Maintenance and Reuse Lab in the Department of Computing Science. Sarah leverages mining software repositories techniques to provide automated support for various software development and maintenance activities, including bug detection, library selection, and integration support. This support allows developers to spend less time on mundane activities, while at the same time empowering them with data and explanations that help them accomplish more creative tasks that need their expertise. Overall, Sarah's research improves software developer productivity and improves the quality of the software they produce. Well, without further ado, welcome, Sarah.
All right, thank you so much, Fred, for the introduction. Let me start sharing my screen. All right, so hello everybody. I'm very excited to be here today to talk to you a bit about software development, what goes on behind the scenes, some of the challenges developers face, and how my research helps address those challenges. But before I get into that, I wanted to take a quick moment to introduce my research group, because really all the students on this slide are the main drivers behind the work that I'm going to be talking about today. So as Fred mentioned, at the software maintenance at the University of Alberta, I lead the software maintenance and reuse lab, or summer for short, as we like to call it, with the pun intended on Edmonton's really warm winters. So what do we do at summer? Well, really, our goal is to improve developer productivity. So to help developers write code faster, write better quality code. And why would you really care about that? Why would you listen to me today saying, how can we improve developer productivity? Well, really, you care about software because you're the end users of all the software and you rely on it in your everyday life. So think of the automotive software that runs in your car that you use every day. Think of all the financial transactions you do at a bank, all the Interact e-transfers we all love. There's behind all of these is software that runs to make these kind of services available to us. Ordering things from Amazon, booking on Air Canada or even airplanes themselves, and even simple things like printers. There's software that runs behind all of these things, and we all want to make sure that the software works correctly so that we get the services we rely on. And so behind the software is developers who are writing the software, and to make sure that there's high quality code, we want to make sure that these developers have the support and tools they need to be able to write this code. So now, before telling you how I help developers give them these support and tools, I want to take a step back and give you a bit of background about what goes on in software development and how do developers actually write this code. So really, there's two parts here that I want to discuss: what goes inside the code of a software system and what happens in a typical software development process. So let's start with the first one. Well, really, behind any of the software systems you're using is some code. Now, this code, you don't really need to understand anything on there. It's just an example here. It's written in a programming language, which is similar to a natural language, but it's actually a language that the computer can understand at the end. So it has to translate into something that a machine understands at the end. And as part of a software system, developers write lots and lots of this code. Now, this code typically implements the functionality they're trying to offer. So, for example, in your banking system, doing a transfer or checking your account balance or something like that. But as they're writing this code, there's typically some functionality that is very common across really a lot of software applications and a lot of domains. So for example, at some point in time, there's data that's going to be stored somewhere. And as part of the system, the developer wants to connect to this data that's stored in a database. Now, this is such a typical functionality that they're not going to keep, reinventing the wheel and writing this code over and over. Maybe they don't even have the domain expertise of how to write code that connects to a database. So instead, they're going to rely on an external library that provides this functionality for them. So in this case, the external library helps them connect to this database. And so kind of all these components together represent a software system. Some of the things that developers write, other external things that they rely on. And this library in the end is also just a bunch of code. It's just code that is already written, tested, and available for other developers to use. So for the purposes of this talk, I really want you to think of a software system as a puzzle. So developers are trying to put these pieces of the puzzle together. So some of those pieces are external libraries that they depend on. Then they have to write a bunch of glue code to make these libraries work together. And of course, there's the custom code that's the specific functionality or the custom functionalities that's specific to their system. Now, to be able to use a library has to tell the developer, how to be able to access the functionality that's inside it. And so the library offers what's called a programming interface, or it basically tells us, what commands to use to access the functionality. So for example, to connect to a database, the library in its documentation would say, okay, you're going to call this command or call this function called connect to DB and give it the database name here. Or to execute a query, it's going to say, okay, you need to call this function called execute query, give it a database name, and give it the query that you want to execute. So now that we know what goes inside the code of a software system or kind of these different components, let's also look at what goes inside a typical software development process. So now developers are writing all this code. Now, they're not writing it alone. They're usually writing it as a whole team that needs to collaborate and communicate together. And so to facilitate this communication, to make things a bit more systematic, developers usually rely on what's called a version control system. Now, what is a version control system? It's basically, as the name indicates, it's keeping track of different versions of the software or the code that they are writing over time. So developers typically write the code and then check it into this version control system. What this helps with is that if something goes wrong, they can go back to any point in time and say, revert to version 1. or revert to version 2, or even just kind of go through these and understand what changed over time. So think of when you're using Google Docs and you could see a version kind of edit history of who your collaborators are and what they edited. This is exactly kind of the same, but for code. Now, another system that they developers really rely on is bug tracking systems or issue tracking systems. Now, unfortunately, as much as we'd love software to be perfect, it's not. And defects, or commonly referred to as bugs or issues, happen in a software system. And so we need a way to track it. So when, for example, developers are testing something and the test fails and they want to report that something went wrong, they can actually systematically report this and track when this bug has been closed, who closed it, and how it actually got resolved. And because these two types of systems that support the development process are so important and so essential, there are whole now services and support tools that are built around them. So one of the kind of essential services that came about in the last 10 or 15 years now is GitHub. So GitHub is basically a social coding platform that provides developers with version control systems and bug tracking systems and a lot of other communication mechanisms that help them track what's happening in their system and help them communicate with each other. So think of this as Facebook for coding kind of thing. Developers check in their code, somebody else can come and comment on it, they can change things and communicate together through various means. Now, another important system that came about to help developers accomplish their tasks is Stack Overflow. So Stack Overflow is a question answer website. So think of this as Reddit, but really just for more technical content, where a developer can ask a question about, how do I use this library to connect to a database? And somebody can answer this question to tell them how to do it. And there's a lot of communication also that happens. And why am I telling you about all this kind of the process and the systems is because I want to drive the message that developers are really leaving behind a trail of data that we can leverage. And at this point, you might be wondering, what can we leverage this for, or what's wrong that we need to leverage this data for? So now that we understand what's available, let's take a different view and look at the challenges that developers face and go back to this to think about the data that we have and how we can use it to help them. So let's take Alice here. So Alice is a software developer, and she wants to store and retrieve data from a database in her application. And because, as I talked about in the beginning, this is such a common task, the first thing that Alice will think of is, which libraries are available to support my task? And as any good software development, or really as any person at this point who's trying to approach something they don't know about, Alice is probably going to start Googling and searching for this question, which library would support retrieving data from a database in her application. Now, quickly, Alice will realize that there are so many choices that are available. She's going to start reading different blog posts. Google's going to, bring links from 6 or 10 different libraries that address what she needs. And she's going to be lost in all this information, trying to think which one is best for her. And to be able to answer this question, she's going to spend time and effort sifting through the information and trying to distill what library is best for her. And this is even a more difficult task if Alice is a novice developer and maybe doesn't have a lot of experience with these libraries. So this is the first challenge or problem that I want to talk about today is how to help developers select software libraries. And you might wonder, is this really problematic? Who cares? Let Alice choose whatever library she wants to use. Well, the problem is that there could be negative repercussions and consequences of choosing a problematic library. So in 2017, there was actually a really big data leak, Equifax, which is the credit score kind of tracking company in the US. And this was actually caused by a vulnerability, security vulnerability, not in the code of Equifax itself, but in one of its dependencies, or basically a library that Equifax depends on. So you can see that if you choose a library that has problems, this at the end, has repercussions on your end product or your end software. And it's not only about security. So for example, if you choose a library that is slow, this will slow down your own application. Customers using, let's say, your website or using your banking service will start getting frustrated and complain, and you lose customers. or if there's any functional problem. So if there's any incorrect behavior that the library is doing, this will again reflect on the end product that you as a developer are building. So what this really means is, in the end, if you choose a library that doesn't match your needs or that has problems, you're going to end up spending time and money to change to a different library. And all know we don't want to spend more time or more money. Now, let's assume Alice, figures out all this information and finds a library to use. Her next task is to figure out how to use this library. And research has shown that actually using libraries is hard. Despite all the advantages of avoiding reinventing the wheel, it's not always straightforward to use libraries. For example, there's typically bad documentation associated with these libraries. If you ever speak to a software developer, writing documentation is one of their least favorite tasks. And so a lot of the time, libraries are not well documented. There's sometimes insufficient or inadequate examples of how to use this library, or no reference of how to use it to accomplish a specific task. So sometimes they say, okay, here are all these functions or commands you can call, but not really how to piece them together to accomplish a specific functionality. Or sometimes if something goes wrong with the library, it's just not easy to debug the library behavior. And so all of this basically means that developers can incorrectly use a library. So what does this mean? So if we go back to our database example, so let's say that Alice writes this piece of code. So she's trying to get some customer names from a customer database. She uses the promised, functions from this library, and everything works well. She can retrieve the customer names. But after a while from running this application, she realizes it's getting really, really slow. So this query is taking a longer time to execute, or her application in general is taking a longer time to execute. And after trying to debug this and figure out what's going on, Alice realizes that the library mentioned somewhere hidden in the documentation, not really very obvious, that she should call close database connection after each time she connects to a database. Otherwise, there's a lot of connections going to this database, and this can basically run out of resources and slow down the database queries. And so the important thing to notice here is that Alice didn't get any errors. The functionality was working well, but there was this implicit expectation that you should do something. And if she doesn't do it, then something kind of an incorrect behavior or undesired behavior happens. So really, the second problem that developers face when using libraries is to make sure that they've used these libraries correctly. And these are basically the two problems that I'm going to be talking about today, is how to help developers with code reuse through libraries, making sure they can easily select libraries and make sure that they use them correctly. Okay, so let's take the first problem of selecting software libraries. And really the question that we're trying to answer here is, which library should I use? And when we started thinking about this research, we thought, okay, how do we choose products or other services in our daily life that have nothing to do with software? And we thought about how you, for example, shop on Best Buy. So typically, if you're looking for a monitor, for example, now, like a lot of these websites offer you comparison functionality. So you can compare these 3 monitors, and it would give you here features or specifications that are related to this product. In this case, for monitors, you care about the resolution, the screen size, refresh rates, if it has HDMI inputs or not. And it's not really telling you which one to choose. It's kind of empowering you with information so that depending on your use case, you might say, okay, yes, the one in the middle is the best one for me. And so we thought, why don't we give developers the same kind of shopping experience for libraries? So here, what we want to do is to create a metric-based comparison of software libraries. So give them some metrics that make sense in the context of a software library, provide this information, and depending on what things are important of highest priority for the developer for this project, they can select the best library to use. And the first thing that is hard here is, what are the criteria or aspects that we should use to compare these? So what do developers care about? For something like monitors, it's clear, what things to use in this comparison. But for libraries, what do we use? Or in the end, libraries is software. So really, what do we use to compare software products? So we found that the developers actually care about community. They want to make sure that there's community around the library that they're using so that they can ask their questions, so that they can find help if needed. They care about the maturity and stability of the library. So they don't want to use a library that's, being changed every day or not being changed at all, or like maintained at all. Of course, they care about the quality. They want to make sure that they're using high quality code so that there's no repercussions on their end product. And measuring these aspects is really hard because all of these are qualitative aspects. How do you measure them? And so what we thought about is, okay, we have this trails of different data that developers leave behind. And some of those data can be used to create metrics that give proxies for these kind of information about community or quality and so on. So what we wanted to do is make sure that we can automatically extract these metrics and that they are quantifiable and comparable. So we really want to make this as much as possible an objective comparison so that developers have all the data they need. And so thinking about these kind of three aspects that developers care about, for something like community, we thought, okay, people will want to know, or developers will want to know, who else is using this? How many projects are using this library? How quickly, if there's something wrong, if I open a bug or open an issue, how quickly will I get a response back? Or how quickly will they actually resolve this, close the issue? Or on Stack Overflow, this question and answer website, when was the last time this was discussed? This gives me an idea of, is this still an active library that people are asking questions about or not? So these are all metrics that give proxies for, is there a community around this library or not? Things like maturity and stability, we looked at how many of the changes that the library developers make would break backwards compatibility. And what this really means is that if I'm using version 1 of the library and I decide to upgrade to version 2, do I need to go back and rewrite everything I have that's used this library before? And if that's the case, that's a really bad practice because that's wasting kind of developers' time and is frustrating for them. Release frequency, how often is this library released? You want it to be released frequently enough so that they're adding bug fixes and security, fixing security problems, but not also every day that you have to figure out if there's changes you want to integrate or not. For the quality, we looked at things as the percentage of security issues that, percentage of reported issues that are related to security, and same thing for performance. And then just this gives us a proxy that, okay, if a lot of the problems that the developers who are using this library face are related to security, then that's really a bad sign. And to actually calculate all these metrics, we're using the data sources that I mentioned before. So GitHub, which gives us the version control system, so we know how the code evolves. It gives us the issues or bugs that are reported. Stack Overflow, which is the question answer website. And the only one you haven't seen before on the slide is Jira, which is also just an issue tracking or bug tracking system. It's just a different system that some software projects use instead of GitHub. And so just to give you an example of what are we actually extracting in the background. So given an input library, let's say we want to calculate how quickly will you get a response if you open an issue. So think of this as you had a problem with your TELUS account or something like that, and you open an issue, and how quickly will customer service get back to you? But in this case, these are the developers of the library or the community around it. So we'll basically determine which issue tracking system this library uses, and we can do that from the data that the library provides. And depending on the issue tracking system, we can extract the information. So for example, on Jira, this is what an issue or a bug report looks like. And what's important here is the highlighted information. We know who exactly reported it, when was it created, and when the first comment was in response to this problem. And so we can basically calculate the response time here. GitHub offers similar information, it's just in a different format, and we need to extract that. Again, who opened it, when, and when was the first comment and by who. And so based on that, we can calculate average issue response time for each library and provide that in the comparison. Another example of a metric that I had in there is performance, where we're calculating the percentage of reported issues that are related to performance. And in this case, we're looking at the same issue data, but instead of looking at the time stamps and who's reporting it, we're looking at the content of these issues, so the text inside it. And using a machine learning classifier, we're trying to classify if this issue is related to performance or not. And based on these classifications, we can then report what's the percentage of performance-related issues. So once we calculated these metrics, we said, okay, let's actually survey developers and see if they like these metrics, if they like these metric-based comparisons, if these metrics help them with selecting libraries. And so this is just one example of the results of the survey. And what you're seeing on this graph is on the y-axis, there's a scale that goes from 1 to 5, where 1 is not useful at all. So this metric is not useful at all. And 5 is this metric is very useful. So the higher, the better. And you can see that the ratings, so all these kind of light blue show you these the distribution of the ratings that the respondents, the participants told us, they really vary by metrics. And what we found was that popularity, performance, and security had the highest ratings as the metrics that developers really care about when selecting libraries and want to have more information about. So now that we knew that these metrics are useful, we thought, okay, how will we deliver this to developers so that they can actually make use of these metric-based comparisons? And we have two ways to provide this information. So the first one is a website that we are hosting that shows you these metric-based comparisons. And we basically update this information on a monthly basis. However, the drawback of having a website, it means that developers have to go somewhere and look at this information. So what we wanted to do is also kind of push this information right to where the developers are doing their actual work. And developers do their work in what's called a development environment, so kind of Notepad, but for code, which gives them some additional tooling to write code properly formatted and so on. So we created the plugin for these development environments that allows them to compare libraries right in there. So it would highlight if there's a library we have more information about, and it would let them compare these libraries right in their development environment and replace one with the other if needed. Okay, so now we've basically looked at how we can provide Alice with some more information about selecting a library and comparing the libraries that she's found all over the internet and trying to sift through information to decide which one to use. So what we want to do next is still try to help Alice to check if she's correctly used the library. And so the second problem here is, how do we ensure that a library has been correctly used? And just to remind you what an incorrect library usage here in this context is something like she's called connect the database, executed a query, but forgot to close the database connection. And so we want to flag a code that has the first two calls, but not the last call here. And the way we approach this problem is with the idea of pattern-based detectors. So what are pattern-based detectors in general, even outside the context of libraries and correct library usage? The idea of pattern-based detection in any kind of context is you obtain patterns of common usages and use these patterns to detect rare violations and flag those as incorrect usages. So let's think of credit card fraudulent transactions, for example. So typically, at a high level, your credit card company is analyzing your typical transactions. So for example, we know that it's very common for Bob to pay for gas at a gas station and then go buy groceries. But we've never seen Bob pay for gas at the gas station and then buy groceries and then check into a hotel. So then the check-into hotel transaction seems like a strange one, and maybe we would flag that. So kind of the same idea, but here we're looking at code and what kind of pieces of code we've seen before, which ones are frequently seen together, and using those to flag usages that are missing something, for example. So how do we do that? Well, based on what I've mentioned before, we have access to developer-stored code from systems like GitHub, where we know exactly every version of the code the developer has written. A lot of this is what's called open source, so we can actually access the code itself and look inside it. And so taking this developer-stored code, what we can do is analyze all the usages of this library. So whenever we see a call to this library or this library being used in a system, we can extract how it's being used. So let's say we have those 4 examples. And in the first one, we're connecting to the database, doing a bunch of things, then executing a query and closing the connection. Second one, similarly, but we're doing the other things in a different place in the code. Third one, we don't close the database connection. And fourth one, we do close the database connection, but also in a slightly different order where we do extra things in the code. And so by analyzing these usages and looking at frequently occurring sequences of calls, we can figure out that there's really a pattern here that typically you connect to a database, you execute the query, and you close the database connection. It doesn't matter if you do things in between, but this is a sequence that we must see in the code. And by extracting the sequence or this library pattern, we can basically assume that this is a rule and say, okay, what other pieces of the software violate this rule, or what other usages have we seen that violate this rule? In this case, we would see this third one as this violates the usage pattern that we've extracted, and we would flag this as a problem, a bug, and tell the user that they need to fix it. Now, if you're interested to look more at the detector, this is also available online, and you'll get to see some really cool artwork by Sven, who's the main PhD student behind this work. Okay, so what we're really saying here is that we will flag this usage and tell Alice, please change your code to this pattern that we have. But if we just give Alice this exact information, she's probably going to wonder, why is this recommendation being made? And so we wanted to try to push this further to try to give Alice a reason of why we are making this recommendation to her. And to do so, we turned to a different data source, which is the question answer website Stack Overflow. And I don't want you to read the details of this question. What I want you to focus on is the structure of the information. So we get a question, we get an answer. This answer might contain these little code snippets in gray, and we get some comments on these answers. And so if we zoom in on this comment, it will have, this one is saying something like, it's a good practice to close things explicitly. Any good implementation would have to close the resources when the connection closes. And after this comment was made, the answer was updated to include these missing close calls. So by trying to relate the comments to the updates to an answer, we can get a pair of, this comment provides a reasoning for why this update is necessary. And we can provide this reasoning to Alice. So instead of just telling her, change your code to X, we can say, please change your code to this other code snippet and provide an explanation that this is a good practice and you need to do it to close your resources. So really what I've talked about right now, kind of presenting these two problems, and the message I want to drive home here is that we can leverage data from the own developer traces to provide them tools and techniques to support things like code reuse activities, so reusing a third-party library, and in general to improve the developer productivity, because we're taking away the time they have to spend, sifting through information, trying to understand documentation that isn't very clear, and bringing this information or these tools right to their working environments and helping them find problems faster. And so let me summarize what I talked about today. So I started by explaining what goes on inside the code of software systems, specifically the idea of libraries and how developers may depend on them to reuse code as much as possible and avoid reinventing the wheel. I talked about some of the tools and processes that happen in a typical software development lifecycle and how this provides data that we can leverage later on. I talked about two problems that my research helps with how we can help developers select libraries and how we can ensure the correct usage of these libraries. And mainly kind of how I'm solving these problems is by leveraging data from developer traces and using this data to provide tools that can support them. And with that, I'd like to thank you all, and I'll be happy to take any questions.
Well, thank you, Sarah, for that great presentation. So we come now to the Q&A period, and right now it's more of a C than a Q or A, as in it's a comment from someone who says, an anonymous attendee, who says, excellent job, this is a great topic. I've run into many of these same issues. Thank you for voicing many of my concerns. So I don't know if you necessarily have a response to that, Sarah, but certainly somebody in the audience very much feels seen.
That's great. Yeah, I think a lot of these are problems that developers run into. And I think it's especially becoming more common with how much software development is attracting more and more people, and there's a lot of novice developers or even people switching from other fields, and so a lot of this trying to decipher how to use a library is very hard. So yeah, I'm glad that this is ringing some bells.
Very on point. Lee asks, can code be copyrighted so no one else can use it?
So that's an excellent question. Yes. So even when it's open source, there are many types of software licenses that are available. Some allow the code to be reused in any possible way, so even complete copy paste. Others says, okay, you can reuse it and modify it, but you have to attribute it to the original developer. And then of course there's or actually you can also reuse it but not for commercial purposes. And then obviously it can be a closed source and you cannot, it's copyrighted, then nobody can use it.
Right. So here's one. It sounds a little technical. From Warren Gallen, he asks, which IDEs does the plugin work in?
Okay, yeah. So right now we have it supporting IntelliJ because, as I think some of the other comments, we've been working mainly for Java. So yeah, IntelliJ is kind of the most popular IDE for Java right now. So we've been using that.
Right, and here's another question that I think touches on the same question. Are you generalizing your tool set for use beyond Java? Maybe something in the future?
Yeah, it's a great question. So right now, a lot of my research is on Java, but in the last year or two, I've started looking into Python more because also how popular it's getting, especially with kind of data science applications and so on. So, I mean, none of the techniques are language specific per se, but the tooling behind them and how each language behaves and the syntax and structure obviously differs. So you have to take some of those considerations into account.
Right. So Von Seward asks, can you speak more to what AI was used by your tools?
Yeah, so for the pattern mining for the code patterns, it's not even a fancy AI. This is basically frequent subgraph mining. So we actually represent the code as a graph, and then we use frequent subgraph mining to extract common subgraphs. And basically there's a frequency threshold. Now for the classifier for the performance issues, we were just trying it out with a naive Bayes classifier. And this is one of the areas we want to improve, trying to use more sophisticated machine learning to actually detect, let's say, performance issues and so on.
Great. Jean-Pierre de Villiers asks, can you rank overhead, i.e. the amount of preamble support code to make use of a single feature in a library?
That's a great question. I don't have a specific number to give you, but when we were looking into cryptography libraries in Java, there was a lot of overhead. So let's say to just encrypt the piece of data, I think there was like 4 or 5 basic calls you had to make to get that functionality. And we surveyed developers, and that was one of the complaints, like kind of all this boilerplate code that you have to write, and that it might have been better to just have one function that abstracts all this functionality. So I don't have a specific number, but sometimes it can be as much as 4 or 5 kind of lines of code just to get a very basic functionality.
Okay. And then I'm not going to try to pronounce this. Tsahasi asks, or comments, I guess, initially, seems to be creating a virtual mentor or educator and set for best practices for coders. Then asks, is there a potential to push specific reviews to expert developers to augment the knowledge rather than relying on passive knowledge construction, perhaps especially for more commonly used libraries or libraries projected to have high future use?
So let me try to decipher the question, make sure I got it correctly. At least I'll say my understanding. So by passive, you mean we're telling them, hey, it's better to do this, but we're not forcing the change. And you're asking if there's maybe something that actually forces these changes. So I think this really depends on the software processes followed by each teams. So some teams have enforced practices. So let's say whether it's stylistic or certain code bugs, that they just not allow, like certain practices of how you write the code. And these are enforced by specific automated checkers that when they try to check in their code to this version control system, it would not even allow them to check it in. So there are ways to enforce some of this, but it is really very specific to the practices of each team and what they consider as, this is a deal breaker versus this is something we can tolerate.
Okay, thanks very much, Sarah. So I think we've come to the end of our Q&A file. If there are no other questions, I guess I'd like to thank you once again for your great presentation and for the lively discussion we had afterwards. And I want to thank everybody for joining us today. Please watch for a post-webinar email that will include more ways to connect, opportunities for how you can support research and programs such as Sarah's in the Faculty of Science, plus additional resources and a way to share your feedback. So it's May, and we're going to take our usual summer break from Science Talks. But over the next few months, you'll see an edition of New Trail hitting your inbox or mailbox in early June, and you'll hear about our plans for U of A Days in September, formerly known as Alumni Weekend, which is an opportunity for the university to open its doors to alumni and the community and celebrate the impact of the university, our research, our alumni, and our students. So you'll see a special edition of Science Talks happening during this 4-day event. And I'm really looking forward to welcoming all of you back to campus to celebrate with us. So until then, please take care of yourselves and please stay in touch.